Hi everyone, my name is Thomas Kim. Today is November 16th, 2019. This is my 29th episode about linear algebra and the threading building blocks. 2 days ago, in episode 25, C++ debugging technique and parallel matrix multiplication, I implemented sequential matrix multiplication, then converted to parallel matrix multiplication. From sequential algorithm, then I made a small tweaking, then converted to parallel algorithm. And today, so after 2 days later, I did profiling my parallel matrix multiplication. I am building using GNU Compiler with optimization switch 03 and using Intel threading building block. Hit enter, I compile CLS. So this is 10 by 10 matrix, element type of float. In case of canonical sequential algorithm, it took 834 milliseconds. In case of standard for each parallel algorithm, it took 14.9 milliseconds. So my simple parallel algorithm is 55 times faster than sequential algorithm. If I try again, also gives the same result. My current episode continues from episode 24, episode 25, episode 26, episode 27, episode 28. If you want to follow my current session, you have to watch from episode 24 to episode 28. From episode 28, click Show More. From Download Source Code section, double-click this link to download complete source code from our previous episode. Show in folder, unzip it, rename, 29, profiling, parallel, matrix, multiplication. Hit enter, copy, paste it to your working folder. This is my working folder. Start Visual Studio Code, open the folder, expand folder 29, open matrix2d.hvp, scroll down. In this section, we implemented this code in our previous episode, probably episode 25. So, if this part of code is unfamiliar to you, you probably have to watch episode 25. And this is a little bit unclear or not good. So I will delete this part and I will fix like this. Template, type name, matrix type 1, type name, matrix type 2, type name, matrix type 1, talk play fun, remove, CV reference T, matrix type 1. Copy once again, paste. This is matrix type 2, type name, return type, matrix 2D, using enable if same T, std, enable if T, std is same B, matrix type 1, matrix type 2, and std is same B, matrix type 1, matrix 2D, return type. If you haven't watched my previous video, you may not understand this part. Now scroll down to the end of this matrix file. Here, we implemented this parallel matrix multiplication in episode 25. So you have to watch this video. If this code is unfamiliar to you, so I will fix this part. template, type name, matrix type 1, type name, matrix type 2, print, enable if same t, matrix type 1, matrix type 2. Now we have to fix like this, and I will remove this code. This code is redundant, and I will change it. Cut, paste, cut, paste. I will modify this part of code, and the remainder is same. Now click this button, open ParallelHVP. We also implemented this file in our previous episode. From here, I will change concurrency limit to 10. Now I will create a file. Click, copy, paste, rename, profiling, hit enter. Then void profiling parallel matrix multiplication. Copy this function, paste it here using element t int. We will start with int, size t, row count. We will start with 10 using matrix t, matrix aligned, fast matrix, element t. We define the matrix type, auto generator. We define random number generator, chr, chrono random, random number generator, element t. We will generate from -10, 10. We define matrix, matrix t, a, row count, matrix b, row count, matrix c, row count. So we define the three matrices, chr, random field, a, array, generator, chrono random, random field, b, array, generator, string. Now we display the contents of a matrix A, and there. I will copy once again. This is B. Now here we build start command prompt dir cd 29 profiling parallel matrix multiplication clang std c++ 17 profiling .cpp ltbb malloc. I will give optimization switch on 3. Hit enter. Sorry, 803. I made mistake here. It should be 1. Okay. Then we build again. 803. 1, 2. We build again. CLS. So these matrices are created at random. Now I will close this file and I will also close it. I will also close it. Only left profiling. From matrix multiplication, please note that this is the code we developed in our previous episode, probably episode 24. If this code is unfamiliar to you, you have to watch my previous episode 24. I will copy this code, and paste it here. I pasted it here. Canonical sequential matrix multiplication. It computes C, matrix C, so we display stream C, and there I will shrink the size, for example 5. Then we create another one, auto D A times B. This is parallel stream D, and there. Now we build again. CLS. So this is matrix A, this is matrix B, A cross B. This is sequential algorithm. This is parallel algorithm. The result is the same. This means our parallel algorithm works correctly. Okay, this confirms our parallel matrix works correctly as a sequential one. Now we do profiling. Now I change it to float. Now it is 10,000 element. So this is A, B, C, D are 10,000 by 10,000 matrices. Okay, because we specified row count 10,000. It's too big, so I will disable this part. Ctrl K, Ctrl C. We cannot display. These are too big. Now this part, I introduce chrono random stopwatch SW. After computing, right before display, we don't need to display. We can't. It's too big. Right after computation, double sequential SW elapsed. This is microsecond. No, millisecond unit. Millisecond units. If you want to change the unit, you can provide like this. CHR micro T. Then you have micro T, microsecond. If you want to have a second, then SEC second T. You can specify a unit like this. This is microsecond unit. Now we do parallel multiplication. This reset stopwatch. Elapsed, resets stopwatch. Okay, so here double parallel SW elapsed. Now we display the statistics. Stream canonical sequential milliseconds, and there I will copy once again std for each parallel unsequential. This is parallel algorithm. Then it is parallel stream sequential over parallel sequential over parallel and there. Now we are using clang compiler optimization switch using Intel threading building block. Hit enter. CLS. So canonical sequential algorithm took 544 milliseconds. STD parallel 4 using fast and sequential 13.9 milliseconds. Farrell algorithm is 60 times faster than sequential algorithm. Now using GNU Compiler, CLS, GNU Compiler, this is sequential algorithm, this is parallel algorithm, 49 times, almost 50 times faster. I started again 50 times faster. So parallel algorithm in case of GNU compiler 50 times faster. In case of clang compiler, it's over 50 times. Parallel algorithm is 56 times faster than canonical sequential algorithm in case of clang compiler. We can also try with Microsoft compiler, dir cd 29 profiling parallel matrix multiplication cl ehsc std C++17 O2 optimization switch profiling .cpp TBB malloc lib fe m.exe. So we are using Intel threading building block and profiling with the optimization switch O2. Hit enter. We build CLS. So Microsoft compiler 14 times faster. Let's try once again. 15 times faster. Why it's such slow? So in case of Microsoft compiler, 15 times faster. But in case of GNU and clang, it is over 50 times faster. Wow! See? In case of clang compiler in parallel, it took 15 milliseconds. In case of Microsoft, it took 55 milliseconds. So clang compiler is much faster. Clang and GNU compiler always wins over Microsoft. I will upload complete source code to my website. By the time you watch this video, in the description section, you can click episode 29. By clicking this link, you can download the complete source code of this episode. Please download it on your machine and try it by yourself. In future episodes, I will deal with more advanced matrix operation such as Gaussian elimination, system of linear equations. Please subscribe to my YouTube channel. Thank you for watching.